Welcome to the deep dive. Today we're getting into the nitty-gritty of microservices. You know, that elegant but essential pattern, transaction log tailing.
Yeah, it's funny how that works, right? Like it's often overlooked. But honestly, it's really the key to understanding how data flows in a distributed system. It's reliable.
Okay, overlooked, but key, you say. You've piqued my interest. And luckily, we've got Chris Richardson. He basically wrote the book on microservices.
Oh, yeah.
And we're diving into excerpts from his microservices.io site, which, by the way, if you don't know it, it's like the ultimate guide to microservices.
Oh, yeah, he's the authority.
So Richardson, he starts off with this concept, transactional outbox. And before you zone out, think of it like your email outbox. Like you write an email, it chills in the outbox, right?
Yeah.
And then you hit send, bam, it's off to the recipient.
And in the world of microservices, that recipient is usually a message broker. It's like the system that makes sure everything is talking to each other, smooth.
Okay, I'm with you. We've got the message ready to go. But here's the real question. How does it actually get delivered? That's where this whole transaction log tailing thing comes in, right? Sounds kind of sneaky, like something out of a spy movie.
I know, right? I kind of like it, actually. So picture this. Your database, it's got this log, right? It's like a diary. Every little change is recorded. And transaction log tailing is basically saying, hey, watch that diary closely. Every time there's a new entry, like something in the outbox, immediately forward a copy to the message broker.
Clever. But why go through all that?
Yeah.
Why not just have the database send the message directly to the broker?
Good question. See, in a distributed system, different parts of your application could be spread out, like on different servers even. So direct communication, it can get messy, messages lost, duplicates, stuff gets out of sync. But transaction log tailing, it links sending a message with the database's own way of keeping track of changes.
So it's all about that guaranteed reliability, especially when you've got all these independent services depending on each other.
Bingo! And here's where it gets really cool. Richardson, he points out that this whole pattern helps us avoid two-phase commit, or 2PC for short. It's a way to coordinate changes across databases, but man, it can really slow things down.
2PC already sounds exhausting.
It's a pain. It's like trying to get a decision from a bunch of people in different time zones. Lots of back and forth. Transaction log tailing. It makes publishing a message part of the same transaction as updating the database. Like everyone's in the same room, decisions made right there on the spot.
Okay, so less complexity, more accuracy. Sounds like a win-win to me. But this is software development, so there's got to be a trade-off somewhere, right? What's the catch? Yeah, spill the beans. What's the downside here?
Right. Well, Richardson does mention that this pattern, it can be a bit, obscure, even though it's getting more popular.
Obscure, huh? Why is that? If it's so great, why isn't everyone and their dog using it?
Well, for one thing, it often needs like special solutions depending on which database you're using.
So one size doesn't fit all.
Not exactly. Like you've got MySQL with its bin logs, right?
Right.
Then Postgres has its write-ahead log, totally different thing. And AWS DynamoDB, they use table streams. It's like each database has its own lingo for talking about changes.
So you got to be fluent in database to make this work.
Pretty much. And even then, making sure you don't publish the same message twice, that can be a real headache. It's like, how do you make sure you don't accidentally invite someone to a party twice, even when the invitations are coming from different places?
Oh, yeah, I can see how that'd be a recipe for disaster.
Exactly. It takes like a deep understanding of how everything's connected and a really careful implementation. But hey, that's what we're paid for, right? Solving these tricky puzzles.
Right. Now, Richardson, he mentions this pattern often works with the transactional outbox thing we talked about earlier. They sound like partners in crime or something, but how do they actually work together?
Okay, so think of it this way. The transactional outbox, it's like setting the stage. It's that dedicated outgoing messages table in your database, like a really organized mailroom. And transaction log tailing, that's like the super efficient mail carrier whisking those messages off to the message broker the second they appear in the outbox.
So one stores, the other delivers. A perfectly synchronized dance.
Exactly. Each one's super important for making sure those messages go through reliably between all those microservices.
Okay, but are there other ways to do this? Or is transaction log tailing like the end-all be-all solution?
It's powerful for sure, but it's not the only way to skin this cat. Richardson mentioned something called the polling publisher pattern. That's another option.
Polling publisher. That doesn't sound as, well, elegant. Like constantly checking your mailbox to see if anything's there.
Yeah, kind of. Imagine, instead of that direct line we get with transaction log tailing, you've got this service that's always checking the outbox for new messages. Then it sends them on to the message broker.
So it's like having a middleman making the rounds. I can see why Richardson likes the tailing approach better, much more streamlined.
Right. And with polling, you've got this overhead of constantly checking even if there's nothing there. Kind of like those annoying phone notifications even for spam.
And I'm guessing there's a bit of a delay with polling too, right? Whereas tailing is pretty much instantaneous.
You got it. The more often you check, the faster the messages get through. But check too often, and you're wasting resources. Check too slow, you get delays. It's a balancing act.
So it sounds like transaction log tailing wins for speed and efficiency then.
Most of the time, yeah. But it all depends, What does your system need? What kind of database are you using? How much complexity can you handle?
Right. The right tool for the right job. Speaking of tools, Richardson mentions his book, Microservices Patterns. I'm guessing he goes into all this stuff in way more detail.
Oh, yeah. It's a goldmine of information. All kinds of patterns, best practices for microservices. If you're working in this space, it's definitely worth a read.
Okay, adding that to my reading list. He also mentions this thing called the eventuate tram framework. What's that all about?
Now, this is where things get interesting. It's a framework that he built. It actually implements the transaction log tailing pattern, among other things, designed to help developers build these really robust, scalable, microservices-based systems.
So it's like a pre-built toolkit for building these complex systems.
Exactly. It gives you pre-built components and stuff that makes it easier to implement these complex patterns, like the ones we've been talking about.
So it's like having an expert on hand to guide you.
Pretty much. It does a lot of the heavy lifting, so you can focus on the unique parts of your application.
That's amazing. It sounds like Richardson's not just talking the talk here. He's walking the walk, providing real tools to put these ideas into action.
Absolutely. That's what's so great about his work. It's not just theory, it's practical too.
So, to recap transaction log tailing, it's this elegant way to make sure our messages are delivered in microservices. And it's just one part of this whole world of building complex systems. I feel like we've only scratched the surface.
There's always more to learn. That's what makes it so cool.
Totally. So next time I'm using an app, and it's working perfectly, I'm going to take a second to appreciate the magic of transaction log tailing going on behind the scenes.
And the awesome minds like Chris Richardson, who came up with it all.
Couldn't have said it better. And for our listeners who want to learn more, check out the show notes. We'll have links to Richardson's book and the eventuate tram framework. Time to go down that rabbit hole.
Happy exploring. Remember, a well-designed system is beautiful.
Totally agree. Well, that's a wrap for our deep dive into transaction log tailing. Until next time, stay curious.
And may your code always compile.
And you can now follow Code Impact Podcast on Apple Podcast, Amazon Music, Spotify, and other podcast networks. It really is mind-blowing when you think about it. Like, we use these complex systems every single day, and they just work. But behind the scenes, there's this whole world of intricate engineering making it happen.
It's like a hidden city, right? Powering all the apps and services we rely on. And it's understanding these patterns, like transaction log tailing, that gives us a peek into how that city operates.
I like that. It's like knowing the traffic patterns helps you navigate so much better.
Exactly. And it makes you appreciate the people who designed it all.
Yeah.
The ones who made it work.
For sure. So to everyone listening, next time your app's working flawlessly, take a sec to appreciate that quiet magic of transaction log tailing doing its thing in the background.
A silent symphony of data, making sure everything gets where it needs to go.
Nicely put.
Yeah.
And for anyone who's as fascinated by this stuff as I am, check the show notes. We've got links to Chris Richardson's book and the eventuate tram framework. Dive in. Explore. It's a rabbit hole worth going down.
Happy exploring. And remember, a well-designed system, it's a thing of beauty.
Couldn't agree more. Well, that brings us to the end of our deep dive into transaction log tailing. Until next time, keep those brains fired up.
And may your code always compile.
And you can now follow Code Impact Podcast on Apple Podcast, Amazon Music, Spotify, and other podcast networks.